think this is, yes, we should be live.
Awesome.
Hooray. I'm going to go over, I always have to check the Twitches and okay. Thing to see if the YouTubes and the Twitches, this is amazing. YouTube beat Twitch this time.
Wow.
I'm not sure. That may be bad news though. Nope. Okay. They both switched over. Yeah. Wonderful.
What this reminds me of with the 4 boxes and people with headphones and stuff is like Power Rangers or like one of those shows where you got the people in like 4 mechs and then they show them all like having a conversation. This is just that. The remote work is just Power Rangers.
It's wonderful. Yep. Okay. This is exciting. We have the Project Tie team on. But before we do that, last time because I did not have audio and stuff working. By the way, if you're watching the show, can you let us know if the audio is working okay for you? Because that's important.
That other guy just joined too. Damien's here.
There's Damien. Hooray.
Hello. Can you hear me?
I hear you.
You're quiet.
I'm quiet? Really?
Yeah, a little bit.
All right. Well, so they hear us. I'm going to rip through the community stand-up links because we've got a bunch and I want to get through them so that we can let you do your thing. So let me check. I'm zinging things all over the place here. They say good audio. Hooray. That's exciting to hear. All right. I am switching monitors. I'm seeing if it works. Oh no, sorry. Oh, it's complicated. I'm not used to both hosting the call and sharing the links, and it's just too much for my little brain. Okay, so we go to desktop, share desktop. Awesome. Let's rip through these. Cool. Okay, so we have 2 from Andrew Locke on, he's been looking at Razor components. So item 1 is he looks at comparing with view components. View components are really interesting. I ended up using them in cases like where you can think of a thing where if you want to have like a shopping cart thing that follows you through a site or like a news summary or something. So they're useful for that. He kind of goes through and explains how those work. Then
John, I want to interrupt. Should we be seeing that on the call or just on the stream?
Just on the stream.
All right.
I see it on the stream.
Okay, we'll just imagine what we're seeing then.
Yeah. Now, if you want to, you can go to live.net, and that's the YouTube thing, or you can go to twitch.tv/Visual Studio. So those will show it to you. It's complicated. If I share it on the Teams call, it's not ideal for sharing on OBS and stuff. So then he also goes into Razor components and compares Razor components and Blazor. And he was looking at a use case that sounds like kind of integrating Razor components in with Blazor inside a server-side web app, like a Razor Pages app, and ran into some places where it wasn't ideal for exactly what he was trying to do. So that's not an indictment of Razor components at all. It was just the fit of what he was trying to do. So for instance, things like partials and tag helpers, not functioning inside, like kind of throwing them all together in one big thing. So
you can't nest them all the way down, right? Like you have to pick. You enter one universe and then you stay in that universe once you've gone into components. Basically.
Exactly. Yep. So picking the right model and not trying to throw it all together. So there's a lot more here, but that's kind of what he kind of settles on. His follow-up post though is kind of a thing of here is a good fit example, and he shows very common Ajax sample, which is cascading dropdowns, which we've all done 1,000 times. This is an example where there's multiple things, cascading dropdowns where you select a country and then that's going to select a province or state. So then he kind of goes through and walks through that sample. And reminder, you're in one universe or the other. You're not going to be happy if you're kind of just throwing it all together, right? So and Damien, we're ripping through these this week. I've got a bunch of links, but I want to give the team time to show their stuff off. So let's rip through. Okay, so 2 on security headers. One from Scott Hanselman. He had his site all set up with the security headers, had an A. Beautiful.
Oh my God.
Yep. Hey there, Scott. Yeah. Hooray. We've got a cast of thousands this week. It's amazing. So Scott, my understanding of this is everything was beautiful when it was set up hosting under IIS. Switching over to Linux, those custom headers, you've got to insert those manually now.
Right. So what happened was I had done years ago another blog post about getting an A on security headers, and by adding all of that stuff to web config, when you are behind IIS goes and does all of that because it lives in system.web server. Then I moved to Linux to save some money and never bothered. I have no tests that tell me that I went from an A to an F. I moved everything into a container and everything broke. So then I basically did a line-for-line translation from web.config to middleware using NWebSec.
Cool. Yep. So not a whole bunch.
Damien is showing off his cameras now.
He needs more monitors. Oh, I can't hear him though.
Sorry, I muted myself. Yeah, I'm not doing anything at all. I'm just playing with my new setup that Scott and I set up today.
I'm very excited about my setup as well.
Oh, yeah, we need a little bit of time, John. Like 3 minutes to show off stuff after this.
Can I do it and jump back to what I was doing? Is that okay?
Yes, but we got to give the Project High team time to show off all their cool stuff too.
All right, 2 seconds then.
Yes. Cancel minutes.
So can you see me? Can you pin me, John, or make me the big head? The big head.
Yes.
Okay. So this is my main camera. We've talked about this before. We're prepping for build. We're trying to make sure that everyone looks good for build. So here's one camera. Here's camera 2 on another webcam. Here's picture-in-picture.
Whoa.
And here is the ever important. Please work. Please work. It's not working. Oh, God. I forgot to turn something on.
It was so impressive when it worked.
We forgot it was going to be so impressive. What was the thing that I needed to turn on?
It's all right. It's practice. It's all practice.
Well, this is important stuff. So it's on over here.
Those fades are really nice, though.
You like the
they are, aren't they?
I'm enjoying those. I don't need the other camera.
You like the fade?
I sped mine up a bit, but
yeah, Scott's are better, Damien. You should rethink that.
I should slow mine down a bit.
Funny thing, you know what's going on, Damien?
What happened?
I'm running Adobe Premiere.
Oh.
And Premiere has inserted itself as a thing. Adobe Premiere has presented itself.
Yep. And so it's
what did we determine?
How much more black could it be?
I didn't install the NDI extensions for CC because I don't use CC.
Well, but I'm a schmuck and I just said next.
You said yes. Yeah, exactly.
What was the thing that was supposed to tell that the iPhone?
Can I unpin you now because it's just, oh, okay.
What was the thing, Damien, that is supposed to listen? How do I get the iPhone to output to?
You shouldn't have to. It's just it was a discrete source in OBS that you added, right? It was a yet another NDI source.
Well, I went in and I said discovery server is this one, and I'm wondering if I had a discovery server.
Don't remember that part.
All right, well, I'll go figure this out. Sorry to bother you, but the point is,
you can open NDI monitor to fiddle around.
Ah, golly whiz. See, all right, call me later. We'll figure this out. I got to figure this out because I have to show this to some people. Anyway, sorry to bother you.
Okay, cool. Ripping through. Okay, so good post from Scott, up and coming .NET blogger. I think he's got a promising future in the blogging industry. Okay, also on the security headers, just by coincidence, here's a blog post from the Elma folks by Thomas writing up security headers, like what those headers actually mean. So I felt like that was kind of cool that they're both we get them both together. One on how to set them up, and the other on what the heck you actually did set up.
I have to say that progress bar on top is like really cool.
Yeah.
Or like how far you are through the document.
Beautiful? Yeah, that's cool. All right, this is interesting. The J project. This is it's an SSO kind of administrator. So you get like an admin dashboard working with ASP.NET Identity, and also with so it's an admin UI for your identity. So like user management and all that kind of stuff. So running on top of ASP.NET Identity. I thought that was kind of neat. Cool. All right. Event aggregator for Blazor. So Mikhail posting about the 2.0 release, and the idea here with Event Aggregator is component-to-component communication. So it's an abstract, like it's indirect communication. I've seen people do different things when you've got complicated things, when you've got multiple components connecting, but this seems to be a popular pattern. So it's that. All right. Post comparing OpenAPI/Swagger, GraphQL, and gRPC. And I was happy to see this isn't like, this one sucks, this one rules. It's more just kind of a, like, here's the fit. Here's where they fit together. Here's the different kind of, good things and bad things about each one. Speed. Speaking of GraphQL, so Saurabh was on the Visual Studio Toolbox show, giving an introduction. So, high-level introduction to gRPC. This is a nice, 25-minute kind of overview. OpenSilver. I don't know what to say about this, but it is interesting to at least mention it. So the idea here is running on top of Blazor and trying to implement the Silverlight API. So this is, I think the kind of sweet spot here is if you have a Silverlight application and you want to migrate it, you want to update it to something more modern, this would be a way. I wouldn't recommend creating a new app using this, but it is nice as a migration thing.
Silverlight.
Okay, cool. This is cool. This was passed over to me by Shane. This is a free workshop on .NET Core, GraphQL, and serverless from Chris. So this is a whole kind of nice, walkthrough of all the stuff, including a cool, like website where you can kind of click through and, beautiful docs and everything there. It's nice. Shahed, continuing his series, this one on logging with ASP.NET Core. So just kind of, Shahed doing his thing. It's amazing quality, nice graphics, explaining how logging is configured, the default logging sources, walking through additional providers, talking through things like exception logging and wrapping up with structured logging with Serilog. I don't think any logging post is complete without wrapping up with structured logging and Serilog. So Sanesh writing about Stack Exchange, Redis extension core. This is the grab a few cups of coffee post of the week, as you can see from the very long slider bar. But nice showing how both, I'll just hop to a few things, showing both the Azure configuration running against the Azure hosted Redis backend, but also he shows several things running through the Redis desktop manager. So, doing local development. I did one project using Redis and I really liked it. It was the .NET Conf. We did some backend caching using Redis and it was beautiful. And using that library also. And then I just figured, as to hop over, I was playing around, I was poking at your docs and I was quite impressed. Folks have amazing docs. And with that, I will pass over to you.
Ooh, it's me. Is it me?
It is you. It's all you folks.
I'm gonna go ahead and I'm gonna get us started here, and then some other folks are gonna jump in. So hopefully you can see. John, let me know when I'm good. You can see the screen.
You're wonderful.
Okay, cool. Well, hi everybody. I'm sort of a frequent flyer here on the community stand-up of late, but maybe we're the Thai team, and maybe I could have folks go through and kind of introduce themselves.
Yeah, so I'm Amy. I am very new to the team. I'm a program manager on the .NET team.
Yeah, I'm Justin. I was on the community stand-up last week or 2 weeks ago now.
Yeah.
Yeah, I've been working on the Thai team for about a month and a half maybe. We really just kind of started the project a couple months ago, so it's been exciting. And previously, I've worked on a bunch of server stuff.
I'm David. I work on, a bunch of stuff and Thai. Great.
No, I work on stuff. You work on whatever.
Oh, whatever.
Yeah. I was filling this out and I realized it's kind of redundant to say like what we work on. Like that's my normal formula for slides like this, or introducing myself to a community member is I like to say what I've worked on that they might have heard of.
Yeah.
But we're here because we work on this. But y'all don't know what it is yet. So I wanna divert for like 30 seconds before we get to Ty. And this is a slide that I made for MVP Summit, which was recent here. And so if you're an MVP, you've already seen this, but if you're not, love to hear what you think about it. And basically, it's the idea that if you're doing microservices development and you're doing like multi-project, multi-backend microservices kind of development, whether or not you're necessarily a true believer in microservices being for you or not, everybody's got multiple backends these days. It's pretty rare to find a production app that is really just one thing or is really just two things, really just a front end and back end. We're all living in this world of having the same problems that people tend to have with microservices. And there's a lot of good content out there about microservices, but a lot of the discussion and the debate tends to focus on this top box, which is how do I break my app into domain-oriented microservices? And since we're the .NET team and we're kind of deeply immersed in the technology, we're the makers of a lot of the technology that hopefully you like to use. We're much better positioned to help you with a lot of the stuff in these bottom boxes. And we're going to introduce Ty today to you as a new project that we're working on that's hopefully going to help take some of the pain away with your development workflow and getting things into production related to most of these bottom boxes here. Some of them we have sort of addressed today and some of them we will address in the future, but hopefully that'll unfold as we show you a little bit more about the project and go through the length of the release. So I'm going to kick it over to Amy for a demo in a moment, but I am going to just call out the name real quick. How we settled on the name Ty, it's sort of tradition in this area to have like nautical terminology. I think Kubernetes started that off, or maybe Docker started that off, but there's a whole bunch of projects that are nautical related, and we chose the name Ty mostly because we liked it and we thought it was a memorable name for a command line tool. It's nice and short, but it turns out to be really good because Ty is our tool for sort of tying a bunch of microservices together, putting a bunch of services together, and that's really like the role of the tie on the ship. It's a big rope that ties stuff to the mast and raises and lowers the sail. So we inadvertently chose a really good name. So Amy, why don't you go ahead and share your screen? I'll let you take control and you can show us what Ty can do.
Okay, sounds great. Let me go ahead and share my screen. Okay. Am I all good? Can you guys see?
I can see on the call.
Yep. Yeah, it's good.
Okay, awesome. So before I kind of jump into the demo, I wanted to go over the different parts of the demo app. So we have a voting sample application, and it contains 5 different services. And the way that it works is that you will cast your vote, and that vote will enter Redis as an entry. And that entry will then be taken in by the worker, who will then take that and insert or either add a new record into Postgres, as well as write the data via Signal R to the results page. And then the results page will then go ahead and display those results. So now I want to, let's see, go ahead and just kind of show the code. So this is kind of the code for the sample application. So we have our different projects, local projects. So we have the results page, the vote page, and as well as the worker. So this application is pretty simple, but we've kind of broken it up into different parts so we can show some of the common problems that people have when trying to run multiple services at once. So there's not a lot of solutions out there that help make it easy to spin up and run your applications locally today. So with Ty, we have a command called tyrun, and tyrun will take all of our services and spin them up and run them locally. So I'm going to show you guys how that's done. So here in the terminal, I'm going to do Thai run. So that's going to execute, and we're going to see that it built our 3 projects. So you'll see the voting project, the worker, and the results project. You'll also see that it's running 2 containers, one for Redis and one for Postgres, which are our external dependencies. And it also creates this dashboard. And this dashboard allows you to be able to see the current status of your services and application. So we're going to go over to the dashboard so I can show you guys what that looks like. Okay, so here's the dashboard. The dashboard shows you, like I said, all of the different services that you're running, along with the different bindings, which are just the ports where all of your services are running at, as well as logs for each one. So, for example, we can view the voting log here. So now let's actually go and cast our vote. So here you can see the results page. I haven't selected. So here we're going to choose whether we like cats or dogs more. So I'm going to go and.
Dogs.
What was that?
Dogs, not cats.
Dogs. Cats are clearly better. So
Cats. Team cats right here.
I'm going to vote for cats because cats are awesome. So I'm going to cast my vote. So here in the results page, we should see one big pie chart showing that we have 1 vote for our cats. So going back to the dashboard now, we can view the worker log, and we'll see that the worker got a new vote from Redis, and B represents a vote for cats. And we can also see that the worker has written the data to Postgres, as well as using SignalR to call the other clients with the updated results, which then just displays here on our results page. So this is the pie chart that you guys see. So I also want to talk a little bit about like how a lot of this stuff is working on the back end. So we have like this Thai.yaml file. And here, this just gets generated, and it contains like all of your different projects and creates them as services. It also contains like your Docker images as well, and the binding ports, which we automatically choose for you, so that way you can avoid things like port conflicts. So this is essentially the YAML file that you can configure as well to add any additional projects or dependencies that you want for your application. So this is how Thai run works and how you're able to kind of spin up and run all of your applications at once. So
can I ask a quick question? You said it gets generated and it's got all the ports and all that stuff, but how did it know about like the dependencies like Docker and Redis and that kind of stuff? Is that something where you configure some of that and then it generates based on the dependencies you've told it about? Am I asking a dumb question? I don't.
No, it's not a dumb question. So with we have another command, Thai init, that will generate one of these files for you.
Okay.
And it's based on what's in your solution or what's in your like current directory. So we don't have the ability to know that you need Postgres or what image Postgres is or how to configure it. I kind of like the idea that we'd have some recipes for common stuff like that, but we don't have anything that does that today. So you do have to know what you actually want to run.
Yeah, the Thai init will do that. And so this is how Thai run works. And next up, Justin will talk to you guys about how you can use Thai to deploy your applications to Kubernetes.
Yep. All right. Let me yank the presentation. All right. Can you all see my screen?
Yeah. We're good on the call.
Cool. Am I on the call?
Yeah.
Justin, can you minimize the team?
Oh, yes. Yeah. Yes. All right. Let me do this a little bit.
Justin, show your face.
Show my face?
I can't see your face.
Oh my gosh.
I want to see your face.
This
is a live stream. Like there we go.
Yeah. My gosh. All right. So what Amy showed was great. It shows how Thai can be run locally, but a lot of times you also want to be able to publish this to production. So this is a fairly complex application. There's 5 services that are going on. So how could Thai actually be used in order to do that? So I'm going to preface this by a couple of things I've already done. So one thing that I've already done is I've already supplied a couple of things necessary in order to configure Redis and Postgres. By default, when you do a Thai deploy, we don't really know like what the connection string you should use for Postgres and Redis would be and things like that. So if I do get pods right now, I should be able to see all of the pods that are currently running, and one of them is going to be a Postgres. Ryan, can you mute? Sorry. One of them is going to be a Postgres instance, and also I'm going to have a secret for Redis as well as Postgres. Get secrets. I'm going to have one for Postgres here as well as Redis, and this is just connection string information that's that I pre-configured to make this demo pretty much work. So I'm going to do a command called Thai deploy, and I'm going to do interactive because I need to supply my container registry that I would like to use. What this is going to do is it's going to take all of my projects that are currently available, it's going to build them, it's going to create containers for each of them, and it's going to put them in, create a manifest, a Kubernetes manifest that will be used to apply to Kubernetes. So right here, you can see that it's reading a bunch of project information, it's compiling and creating different outputs for each of the applications. It's building Docker images, and it's pushing the Docker images. So this would be the voting app that we saw earlier. It says that I've found some detail or secrets for Redis and Postgres already available. It's doing the same thing for the worker right now, where it's creating the Docker image and pushing the Docker image, and it'll do the same thing for the results page as well. So I have 2 pages that are already the URLs that are going to be there. So I should, as soon as this is all done, I should be able to refresh the page, and it should be available already. Another thing I've already done as well is I've set up an ingress resource to make it so this application is actually available to the internet. So I just used an Nginx ingress YAML file to do that. And it should be wrapping up right about deploying manifests. And it should be good to go right about now. Let's see here. There we go. Cool. So it's already deployed and it's finishing up the command right now. So if you actually go to this URL right now, I believe it should be available to everybody. It's just my IP and then .nip.io and then /vote. You can vote whether or not you want dogs or cats. And then I also, okay, yeah, I'm going to vote for dogs because it's the right answer.
Cats.
Well, too bad. Dogs are
So
the right answer.
it's a web-based voting, not a vocal voting. I think that
it's a web-based.
You must not have made that clear.
Says who?
Yeah, so as you can see, the results are actually getting updated right now with people voting. Someone votes. People are voting for dogs. People are voting for cats. The right answer is dogs, so you should definitely vote for dogs. And the people are voting for cats are incorrect. But yeah, that's the application running. So if I actually do Q control get pods, we can see the 3 pods that are running right now: the worker, the vote, and the results page. If I get logs for that, let's do the worker. Oops, I'll just copy this because we can see logs are coming from the worker itself. It looks like dogs are definitely superior. I also definitely didn't bias it by like voting 5 times for dogs before this to make it so the graph actually had things. As you can see, there's a bunch of logs here saying that we got a new vote from Redis because everything's getting queued into Redis, and then we are putting the results in Postgres and then using SignalR to broadcast it as well. And then we are, I think that's pretty much everything. Yeah, that is pretty much everything with deploy. So as you can see, we have an application running that we deployed successfully to Kubernetes. Cool.
I have a question, Justin.
Yeah.
What would happen? So you showed creating some Kubernetes secrets, or you have some pre-existing Kubernetes secrets. What would happen if you didn't have those?
Yeah, so the beauty of Thai deploy with interactive mode, it allows you to configure secrets on the fly if you didn't have them there before. So let's say we were doing the Thai deploy and the Redis secret wasn't there, but I needed it to make the application actually work. Thai would notice this when you're actually deploying, and you would be able to fill in the connection string when you're doing an interactive deploy. If you weren't doing an interactive deploy, I believe it would just fail to deploy, saying you need the secret to be configured. And that's very useful because like these secrets are usually kind of like a one-time thing. You usually don't need to do it multiple times. Like you don't need to deploy secrets on every deployment. It's just like a one-time configuration. So that's a nice option of Tide Deploy that allows you to configure those.
Cool.
So I got a few questions coming in and along a theme. One is how much of this is configuration, is boilerplate versus config driven kind of stuff. What I'm hearing you say is you're generating configuration based on what you can discover in my project.
Yeah.
And then,
so a lot of it's based off the Thai YAML file. There's a lot of configurations determined from that, but it's also a lot of like well-known techniques that people do for Kubernetes. So for example, when we deploy, we effectively just deploy when we create a Kubernetes YAML file, we effectively just have a deployment and a service for each of your projects. And then we do some necessary things to make it so these services can communicate with each other by setting up environment variables appropriately. Ryan, I don't know if you want to talk about service discovery at all, but I think that's
I've got a slide on that, so we'll just look at that there.
Okay, let me ask one more question, which I think is an interesting one. Giovanni says, "How is this different from right-click deploy?" Excuse me.
Right-click deploy.
Yeah. Which I mean, so yeah, so meaning you typed a few commands and it deployed some stuff. How is this better?
I think the primary way that I would say that this is different is right-click deploy is, first of all, is a per project gesture. The second thing that I'd say about it is Thai is meant to work for local development, for like cheap experiments, like I've got this code and I just want to publish it somewhere. And it's also meant to be used as part of a CI/CD pipeline. So one of the things that Justin didn't show that we have working though is like your Docker files and things like that, or your Docker images and things like that are all going to be like versioned appropriately. Today we use the versioning rules that are set up in your .NET projects for how to version stuff. We'll probably do something slightly better in the future, but like you actually get things deployed to Kubernetes with proper versioning and stuff like that. So it's like the tool is meant to take you from I have an idea and I want to hack it to I want to deploy this somewhere and see if it actually runs to I now have an actual CI pipeline that's working. Right-click deploy obviously can't really work in a CI because it's something a human does.
Yeah.
The other thing that I would say about it, Justin, why don't you do you have VS Code? Do you want to show what's in the codes?
Yeah, for sure.
So some of the things that Thai is doing here that's pretty interesting is Thai has intimate knowledge of .NET. There's a lot of .NET going on inside the tool. And so like what you don't see here, there are no Docker files, there are no Helm charts, there are no Kubernetes manifests. Like we haven't done any of these things. Yeah. There's another demo that we like to do for Thai where we have a front end and a back end web app and they're meant to talk to each other. And we can deploy that to Kubernetes with no configuration. So like you have totally vanilla .NET projects, they're in a solution. Mm-hmm. You then get them to talk to each other with Thai run, and you can deploy it with Thai deploy without doing anything. Yeah. The other thing that I would mention to I think it was Giovanni's question, is that we haven't gotten to yet is that Thai is a very experimental, like incubation sort of project that the team is working on right now. So is the destiny of the things that you're seeing here that they show up in Visual Studio and you can right click to do the same things that we're showing? That's a possible endpoint for what we're doing. So this is a little bit more of an incubation, and we're sort of feeding ideas that are we're growing ideas that are going to drive the state of the art forward in the future. So I would expect to see a lot of more innovative kind of radical takes on stuff right now, and then see those kinds of things either incorporated into other projects in the future, or Thai continues on as a project. Who knows? Okay, one other question, and then I'll let you get back to all your demos. Yeah. A few questions from Alexander asking about, like, does this push you towards a mono repo kind of architecture? Yeah. We haven't. So this is one of the things that we're really curious about, and we're so curious about it that it's part of our like feedback issue template. I would say right now we're optimized for the case where all your code builds together. One of the other problems that we're interested in taking on, and I'm asking because I'm answering it now because it's a very good question. One of the things we're really interested in taking on is having gestures that operate on a single project instead of a repo at a time, or instead of a big thing. We're interested in feedback from people that don't use mono repos and how they would prefer to see things organized. And we're also looking at feature sets that allow us to do like packaging and distribution of applications. So the idea being that you're using Thai, some other team in your company is using Thai, and you can run their services locally by bringing in their manifest or something like that. So that idea hasn't really been fleshed out, but we know that the need is there. I think we're interested in any feedback from anybody doing microservices development on .NET about what are your biggest pain points and what can we do to resolve them.
Cool.
Yep. So let me take control then, and I'm going to jump to our slides. And hopefully we'll probably be answering some of these questions as we continue through the slideware.
Yep.
So we did that. So talking a little bit about local development, which Amy showed us, we automatically choose ports to avoid port conflicts when you're running multiple things. If you today on Mac, I think IIS cleverly avoids this problem, but if you're on Mac or you're running at the command line today and you just create 2 new .NET projects and try to run them, that will not work because of a port conflict. You need some kind of orchestrator to make it so that your applications actually get assigned unique ports for local development to work. And we also have the ability to run containers and other processes for your data dependencies. So whatever external things that you want to have as dependencies to make your app work, we have the ability to run those locally. And we're looking at expanding this set beyond containers and just shelling out to lots of other things that people might want, like they might want to run the Azure Functions emulator, for instance. How we do service discovery, this will get better in the near future. Thai today basically takes the descriptions of what are all your services, what ports are they listening on, bakes that into a big list, and then constructs a bunch of environment variables and config options from those things and feeds them to each other. So within the pantheon of service discovery, there's a couple different levels, right? One level is you could plug in at the network level. Another level is you could plug in at a config level. And then the third level is you could have like a discovery service and things like that. So we're kind of in the middle of those two things. And on Kubernetes, we do a little bit of both. But for local development, we use config. So we'll probably package all this boilerplate that you're seeing here into a library by the next time that you hear from us. We've been copying, pasting a bunch of code in between samples, and we know it's not a good solution. Coincidentally, we're also a libraries team, so we can build libraries. So expect more on that from now. But this is probably similar to a lot of the conventions that people are doing today. You know, when I talk to a lot of users, they would say things to me like, I'm hard coding the URLs and the ports of things in production, and then I'm using environment variables or launch settings or something like that to override them, or Docker Compose to override them for local. So if you can think about how that's kind of annoying to maintain it, or it's kind of annoying to script all that out so that you can just get these 5 things to run and communicate, we're trying to make that as simple as possible. And the way that we do that is basically trying to take the problem of figuring out exactly what these values are out of your hands. How we deal with deployments and how we make deployments repeatable and useful is we use information from .NET to build your Docker images and deployment artifacts. So like I've been on this show, I think the last 2 episodes were both me just blah, blah, blah about Kubernetes. One of the things that we learn about Kubernetes when we get started there is that it's verbose. Right? Like there's a lot of stuff that goes into a manifest. There's a lot of stuff that goes into a service. And if what you're doing is just building web apps, you don't really care that much about customizing that stuff. You just want it to go. So the experience with this today is you don't even have to know these things exist. So if you're doing .NET apps and you don't have a lot of weird requirements, like you don't even have to know that Docker images exist or that Kubernetes exist, and those things that will work for you. And how we deal, this is a sort of lens on how we do configuration and secrets. So over on the right-hand side, you've got a view of what things look like in Kubernetes. Locally, we do a lot of things with environment variables. In Kubernetes, we actually use Kubernetes secrets and map them to disk as well as environment variables. So all of your service discovery concerns, like what URL do I talk to the order service, are just environment variables. All of your actual secrets, like what's the password to my Redis, get put on disk, which is slightly more secure. The fact that we're using secrets in Kubernetes, by the way, is not just meant to be an implementation detail. It's meant to signal a little bit of a handoff there. So like we have a nice interactive experience for configuring secrets for things when you're deploying interactively. But we've kind of thought through like how we want that to work for CI, right? So like if you're trying to deploy something in your CI and you haven't configured all the necessary things to configure, it will refuse to deploy and say, no, I can't do this. Likewise, the fact that we bake things down into Kubernetes secrets could be a point of like handoff for an ops team or people who work on ops in your organization to say, hey, so we're going to put this app in production, and all we need from the ops team is provision a Redis instance however you want to, and then set up a secret with a URL that I can use to connect to it, and we'll take it from there. So right now we're prescriptive about what these secrets have to be named, but we're looking for feedback on if this is useful to people and if this kind of solves problems for you. So that's kind of the gist of the main thrust of what TIE is about. Did we get to people's questions? Did we answer the important questions that people have about what have you seen so far and how does it work kind of things? Because I'm going to deviate into something else briefly if we're ready to move on.
There are a few other questions on things, service discovery with things like console or, service mesh and things like that.
Okay.
So this is a way of doing that service discovery. It's not going to integrate with other service discovery methods. Is that right?
I mean, I think the thing is that if there's a need, like I'd love to hear more from people what they think they would gain out of an integration with something else, because we're going to be totally driven by what people think is challenging, and can we make people's lives better for running .NET apps in production or development. So I think people with really advanced questions, I'd love for you to like go to the repo and ask your question, or like, you can ask it if we have some extra time left at the end, because I think it's worth a discussion with you about what would you want to get out of that. Because the way things are here with TIE, with the service discovery stuff, is pretty simple. It's pretty basic. And I want to know from you what you think what else you think is necessary, or what else you think is needed. You can also ignore it. So if you don't want to use our config, if you don't want to use the values that we set in config to understand how to talk to the service, if you have a solution that you like, nothing's forcing you to call that method. So we don't, we're the ASP.NET team, and hopefully you have a little bit of trust for how we do things at this point as far as baking in things. We try to avoid baking in opinions at the default layer unless they're really useful opinions that we all agree on, and we try to always give you an escape hatch. So I would expect like the service discovery stuff we're talking about with TIE, like those are optional features, right? Like you're calling a method to wire it up. So yeah. Anything else?
I think that's good. We should jump into the rest of it.
All right. Let me show some more stuff then. So one of the things that I heard pretty loud and clear from people when we started talking more openly about TIE is people had heard about Dapper, and they wanted to know, are TIE and Dapper in competition with each other? Can you use these things together? Do you choose one or the other? And what's the point of TIE if Dapper exists? What's the point of Dapper if TIE exists, and so on? And I don't think I've had the chance to talk about Dapper on this show. It's something else that I've been involved in, and David's been involved in a little bit. But basically, there's another team at Microsoft from the Azure team who's building I really think of them as a serverless platform or as a serverless programming model team. So the idea of something like Dapper is we're going to raise the level of abstraction of all the things that you're doing, so you're not so coupled to the underlying platform. So Dapper provides a set of building blocks. Don't give me credit for these slides, by the way. I didn't create them. I just copied them, and David copied them from somewhere before that. Dapper provides a bunch of sort of primitives for building microservices. Service-to-service invocation, which is like RPC method calls. State management using a like schemaless state store. publish and subscribe. So not message queue like functionality, but pub sub like functionality, and then resource binding and triggers, and then there's a bunch more stuff. But the way to think about these things that I think that's valuable is service to service invocation. We know what that is. Like that's calling an RPC endpoint on another service. Like we've written HTTP endpoints and we've written gRPC apps before. We know what that is. State management is an interesting one because it's just a key value store, and they're trying to basically abstract away what your data storage is so that your data storage is replaceable. So you might be using Redis for local development, and you might be using Cosmos DB in production, and so on. And then publish and subscribe, similar idea, right? Like instead of taking a coupling to your cloud providers like messaging framework, instead you would take a dependency on Dapper and sort of bake in the knowledge that you're using Dapper, and then be independent of what the actual like technology is. Likewise, similar to things like Azure Functions, there's a whole bunch of triggers and bindings that you can use to say, I want my app to be called when this thing happens in the cloud. So the really neat thing about Dapper is that Dapper is architected in such a way that all these primitives are surfaced to you as HTTP or gRPC. Because the idea is that every technology stack, every language, and every framework knows how to do HTTP. Most of the good ones know how to do gRPC. And so can we just abstract away all these things by turning a message queue message into HTTP, or writing to the database is turned into HTTP, or somebody uploading a file is turned into HTTP, and then basically get any kind of stack or any kind of web framework working as a Dapper application with a small amount of stuff, with a small amount of buildup. So how this actually works in production is when you're in Kubernetes, you're using a Kubernetes feature that we've talked about, I think, the last 2 times I've been on here, which is that pods can be made up of multiple containers. So you deploy a Dapper application, you put an annotation on your deployment, and then Dapper will create an instance of its service running in your containers like address space. And then you just effectively communicate with Dapper, and Dapper does all the heavy lifting for you to network you with all these other kinds of things. So it's a little bit similar to using a service mesh, if you're familiar with that, but it's not for all network traffic. It's for specific application level features. So I want to show a demo because, after all, we're here to talk about Thai. I wanted to introduce Dapper because we've gotten a lot of questions about Dapper and about how these things go together. So I've got a helpful diagram here. I've built a e-store, like e-commerce kind of application, and it's a Dapper application. And I've got I've got my store front end, and I've got 2 other applications. I've got a product service, which maintains the list of products, and I've got an order service, which is responsible for my sort of like ordering and fulfillment. And I'm going to do all the communication between these services through Dapper. So what it's going to look like to you is I'm just calling some .NET API in my code from the Dapper SDK. But what's actually going to happen is the Dapper is going to send a bunch of gRPC messages back and forth. And then depending on which interaction it is, it might result in data being stored in Redis as key values, or it might result in Redis being used as pub sub, because I'm using Redis for that. But if I were to deploy this somewhere real, I could use a bunch of Azure features or a bunch of AWS features for this. So let me jump to my demo. And I have already got this running here. I did a Thai run. Let me zoom in a little bit. I did a Thai run, and you can see that I built my 3 projects, and I launched my 3 services, and then I launched a bunch more stuff here. And the reason for this bunch more stuff is I have turned on Dapper. Now, here are my 3 projects, and what I've done, I've got orders, products, and store. I've got a Thai.yaml, and the only thing that I've added to this is I've said extensions Dapper. So I've basically said like Dapper equals yes. Is kind of how you can think about that. And so these are very hot bits, by the way. This is not checked in. This is super duper prototype mode. So I'm not going to show you deployment because I haven't implemented that yet, but I will show you this running locally, and I've already started it. So I can go to my local host 8000, and you can see that I've got more stuff, right? Like I only wrote 3 services, but you can see that I've actually got 6 here. Now, the reason I've got 6 is because of that sidecar behavior that we talked about. So we talked about Dapper injecting containers into your pod so that you have a service to talk to. Well, I've basically got Thai run to do the same trick that happens when you use Dapper in Kubernetes. So I've got my 3 services here. I've got 3 Dapper services running here. These are just these little like Go processes, and I can see their logs and everything here. So I can see all the stuff that's going on inside these Dapper services. So let's do one of these communications. So I've gone to my store. It's loading my list of products. So my list of products actually comes from my order service, or my inventory service, my product service, I called it. So this is going over Dapper invoke, and I'll show you what that code looks like. So inside my store, inside this product display, you can ignore some of these errors. I will get Taylor to fix them. They're just bugs with the Razor editor. I'm getting this list of products. So it's not this one. It's in the index. I'm getting the list of products, and I'm getting this Dapper client from DI. And I'm using the Dapper client. I'm saying invoke method async, which means invoke a method on the product service. And the method is called list. I'm just going to list the products. So I'm going to get the products, and I'm going to loop through them, and I'm going to do a display of each product. Then the other thing that I'm doing here is when I place an order, I'm using pub/sub. So when I place an order, I'm going to publish an event on the order place topic. And then I'm basically going to just await for the confirmation. And the pattern that I'm using here, I've written an event broker that runs in the process. And so what I'm doing is I'm subscribing to pub/sub. I'm saying I'm waiting for a response for an order, for this order ID. Then I place my order, and I wait for the response to come in, which is how that works. So if I go back to my store, I need do-it-yourself haircut kit, a book to read, new video game, lots of things that I might want to buy. I really kind of need the do-it-yourself haircut kit, so I think I'll buy one of those. And oh, they're sold out. So there are 3 people ahead of me in line. So one of the things, how can we understand a little bit more about how this works? Well, I mentioned that this is going over Redis. I'm doing pub/sub with Redis. And how do I actually receive that? So let me look at my order service. And I've written a normal ASP.NET Core controller. So the only things about this that are Dapper actually is I've got this attribute here that binds it to a topic, and then I'm just getting the Dapper client from DI like we saw in our Blazor component. So when I get the order in, I'm going to use the Dapper state store, and I'm going to check basically the status. How many do I have remaining? I'm going to decrement it because somebody wanted one. I'm going to save the state. And then I'm going to send an order confirmation, and I'm either going to say, your order has been sent. It'll be delivered a year from now, or I'm going to say, yeah, sorry, it's on back order. You're in line for this long, and I'm publishing that back to another pub/sub topic, and then I'm basically just doing the same thing in my UI application. So my UI application, my front end here, I've got a routing endpoint that is going to map to the order process topic. And you can see I can listen on a URL and map it to a topic with routing as well as with MVC. It's going to send me a little JSON blob, and then I'm going to tell my event broker, hey, I got a completion for this thing. So that's kind of the flow of this. Is how does that all work? Like I go to this page, it loads the list of products from the product service. I place an order, sends a pub/sub message to the order service. The order service responds via pub/sub. We wait for that confirmation, and we can do that thing. So we could try buying something else, and we could see that we're actually able to pre-order the video game, but it's going to come next year. So how does this all work, and how can we understand some of the moving parts that are here, right? So there's a couple moving parts. There's the 3 services, and how I got this is I basically just did a tie init on my dapper.sln, which gives me these 3 services listed here. And then the only thing I had to add to do this was basically say, let's turn on Dapper. What Dapper is doing here is Dapper is actually wired up a pub/sub, message bus, and a state store. And one of the things that's interesting about this is that Dapper is actually managing this like Redis, or I think this is just like running on my machine. It's not part of my tie.yaml today, and I have to manage these configs. So it would be kind of nice if I could put these in tie.yaml, and I could have a little bit more direct integration with Dapper, but I haven't gotten that far with building it. So I just copied this from another sample. So what I have built, though, is the ability to run the Dapper proxies and do that sort of thing. What this would look like if I weren't using something like tie is I would have to come to my command line, and then I would say Dapper run, and I would have to assign each app an ID, so foo, and I would have to assign a port. So because Dapper needs to know what port the app is running on, I'll say 5000, and then I would pass to Dapper the command to run it. So like this is an okay experience because it kind of gives me the basic tools that I want. Where Ty can come in with something like Dapper is basically to help be that orchestrator for you and help do some of those deployment and development kinds of tasks. So even though there's no like service discovery inside of there's Dapper is a framework or an application sort of programming model that brings its own like service discovery to the table. You can still use that with Ty. Like there's no reason why you have to sort of be exclusive to the same set of primitives that Ty provides. It's a little bit more of a menu. Does that make sense?
Yeah. So by that, and this is not an area I know a huge amount about. So, but you've got that abstraction for Dapper. Would that potentially come in handy for other sorts of abstractions similar to Dapper, or is Dapper kind of its own thing?
I think so. So I think the thing is how I would think about Dapper is I would position Dapper as a programming model, and I'm going to go back many slides because there's a reason why I put this slide in this deck. Is that Dapper basically operates like at these levels. They've added secrets, but they basically operate at the communication protocols, service discovery, diagnostics, and observability layers. Dapper doesn't have any opinions about how you deploy your application. They have a few opinions about how you can run it locally, but Ty can do more. And they don't have a ton of opinions about configuration, but they're adding some. So like Dapper is actually solving a bunch of problems that Ty doesn't solve, and it's doing it in a pretty opinionated and like platform agnostic kind of way. So it's really sort of like people have asked the question, can you use these two things together? And I think about it as like, well, we're trying to help accelerate microservices no matter what kinds of things you're doing. So if you like Dapper and you want to use it, like we think it's great too, we can help with that because we still provide some value that's maybe outside of the scope of what they're doing.
Cool.
So with that, I want to say a few more things. That's all the demos that I've got for today. I wanted to say a few more things about what we're sort of doing. So Ty is an experimental project from the .NET team. We're going to be working on this throughout .NET 5. The repo is public. We have bits that you can try out. Most of the things that you've seen here, except for my demos, you'll be able to do with the bits that are linked to there. There's a specific version number that we advertise. You're free to try the nightlies as well. We'll plan to do a big release and make noise maybe once a month. So have actual release notes and talk about what's in it maybe once a month and have some updated samples and demos and things like that. We're in kind of an early adopter sort of phase where we're looking for people to try Ty and engage with it and give feedback and collaborate with us who have got a little bit of experience in this space or maybe no experience in this space and want to help try and resolve what some of your pain points are, either for development or for running things in production. So I think, yeah.
Can I just brag on you guys again? I think I mentioned it earlier, but your docs, your getting started tutorial, really good. And I do recommend for people watching that want to give feedback, like, can you show that real quick?
Yeah, let me show that.
It is much easier than I thought it was going to be. Like I was like, okay, I should, not be completely stupid on this call and I should take a look. And I poked around and I had it running in a few minutes. And I was like, whoa, this is super easy. Like, I mean, and it was explaining stuff pretty well. So anyhow.
Yeah. I think the issue is that sometimes we show Ty with a big example by default. So you assume that it's only required, it requires like containers and stuff. And the sample here takes you from one application to two to a dependency on Redis, right?
You're showing that you can solve these big complicated problems and that that you've solved the big problem space. And for some people on the call, like from the chat, it's obvious that you're solving some solutions and they're like, whoa, this is perfect, But it was nice for me as kind of a newbie at some of this to see how smoothly it worked too. Like I could get going pretty quickly.
Thanks, John. So I'm not sure if we had anything else that we really wanted to say other than we're here for.
I can show a demo. I can show a demo quickly of some really hot stuff we're working on right now. That's totally not.
While you're doing that, if other people from the team could take a look, like if you go, there's a good amount of questions in YouTube. If you go to live.net and you can expand it out, or if you, I can send the link over if you want. But there's some questions there, and I think I've picked some good ones, but I don't know if I've gotten them all.
Okay, so maybe I'll get done with this demo fairly quickly, and then we can have a little Q&A time just to do that. All right, so I wanted to very briefly go over a demo about pretty much what, I guess the idea is let's say you have a Kubernetes cluster that's deployed to production or deployed in a dev environment or something like that. And you have this app that has many, many services. Let's say you have 15 services, but for the sake of demo, I'm only gonna do 2. If you're running this 15 service thing locally, if you have a front-end application and you wanted to get the backend application, you can do a GET request for HTTP localhost with some URL, right? And that would all work. But let's say I wanted to develop this front end locally and I wanted to reference something inside the Kubernetes cluster. So if I wanted the front end to talk to the back end, how would I do that? Well, the problem is that if you have the back end inside Kubernetes and it's totally not being, it's not exposed to the internet at all, the front end can never actually get the back end at all. It just won't work at all because the back end is totally isolated inside of the Kubernetes cluster. So if we were to have the front end inside of the Kubernetes cluster, effectively you can be able to get the backend by doing a GET request for the backend, just with the DNS name called backend. And when both these are running inside Kubernetes, this all works totally fine. So the question is, could we enable a scenario like this to actually make it work? And I have a prototype of this, at least trying to do this in a way that is somewhat effective.
Can you minimize me down in the bottom corner?
Yes,
I think
yes, of course. Cool. I hated the defaults to do that. Okay, so I have a front-end back-end application. This app is fairly straightforward. All it has is a front-end which calls into a back-end. What this does is it gets the information about where the front-end is listening. Let me zoom in a bit. Gets some information about where the front-end is as well as the back-end. I guess my IP information, pretty basic stuff. And the backend itself is just responding with the IP and host name of where it's at. Very straightforward example. So today I have this currently published to Kubernetes. I have a front end and a back end that are currently there right here. So if I were to do a port forward in order to get the front end, I could hit the front end there in order to get the information from it. But what if I wanted to try using a front end that's local as well as a back end that's remote? So I'm going to run a command called, this is all very experimental that I literally just prototyped about 15 minutes ago. Not 15, maybe 2 hours ago now. I'm going to do a command called tie connect, which is going to connect to a Kubernetes cluster. Oopsie. This may not be working. I may have broken something.
Is it dtie?
Yeah, it's tie because I'm using a experimental thing. I may have broken something. Anyways, the demo was going to be me connecting to having a front end that connects to a back end and actually connects your local computer to the Kubernetes cluster to make it so things like calling the DNS name backend actually works. I demoed this to Fowler about 20 minutes ago, and I guess it's not working anymore. But anyways, this is something we're trying to experiment with right now, and we're hoping it's going to work soon.
I just want to make sure it wasn't a typo. It's dtie because it's a separate command for that, right?
It's dtie was totally something I was prototyping with, and it's something I have locally to call my current build of tie.
So that does sound that sounds really useful though. Be able to split them apart.
So we're trying to play around with a lot of things in this area. We're not necessarily sure what what the end story of that is, but connected development seems to be a very common theme of like having something you run locally while the rest of your app runs in production or in a dev test lab or something like that. And we were trying to prototype around with that and figure out some solutions for it. Unfortunately, my demo failed, which sucks. Life happens, though. Maybe next time or whenever it happens.
I would have actually been upset if one demo hadn't failed. This is brand new. You're showing all cutting edge stuff.
I literally got it working about 2 hours ago. I showed David. He was like, "Oh my gosh, it's so cool."
I saw the whole thing.
Yeah,
it was great.
But unfortunately, I'll play around with it and see why it's broken. But I'm pretty sure I was hacking around with it and something happened.
So we're a little over an hour. I don't know if you folks see other questions you want to take, or you also have, for people that do have these more advanced questions too, this is something where you've given the repo, and that's a good place to get in and ask.
I think definitely for people that feel like they have a question about how does this integrate with this, or how can I put it into my existing setup, like probably it'd be very useful to us, I guess. So you could do us a big favor by just logging an issue and just say what you want to talk about, and we would love to have a dialogue with you about it. If it's a question, like if it's a simple question or those kind of things, we're happy to answer now. But we're really hoping that people feel like this is moving in the right direction to solve some of the problems you face or some of the things that are frustrating about your development. If you don't think so, like we'd also like to know why. Like if you have a microservices development workflow and setup that you're really happy with, and you don't see this as an improvement, like we'd love to hear about that too.
Yeah. Just to step in, I actually do have the demo working. I just totally was already connected to the cluster.
We just had to stall for you for a few minutes, right?
Yeah, give me like 3 seconds to finish the demo. So anyways, normally you wouldn't be able to do this. Normally I wouldn't be able to query the backend from my browser, but I am able to refresh with the DNS name backend and actually get the backend. The other thing I can do is I can use tie run, tie run, and then remote as this and local as front end. And this is going to run the front end locally and run the rest of the remote services remotely. So once this actually, this is going to be this is witchcraft. This is totally Mad Catz doing very new things. Unfortunately,
it's not Mad Catz. It's great.
It's great. Sure. Anyways, this is going to show that the front end is running locally while the back end is running externally. And if I actually go to the URL, I should be able to see the front end information locally and the back end information from my Kubernetes cluster. So this is showing effectively this diagram of I have a front end that's running locally. I'm able to call get on the back end and actually get the back end information from Kubernetes.
All
right, that's
from a DNS on my computer. How are you mapping that? What's going on?
There's a lot of magic that's going on. I don't necessarily know how much I can reveal yet, but there's a lot of magic in order to make it so when you do a DNS lookup on that, it actually looks inside the Kubernetes cluster first before doing other things. A lot of stuff, we're still trying to figure out how to get it all working, but this is a little bit of demo magic, but a little bit of some craziness.
Awesome. Well, we're a little over an hour. There are some good questions coming in, but it does seem like it would be good for people to take some of those more advanced questions over to, and also to let us know if let us know when it's time for a follow-up show, and we can dig deeper into this.
Cool. Awesome. Thanks, John.
Okay, thank you. Thanks, everybody. And I'm actually going to pat myself on the back because I didn't blow up OBS and most of the audio worked. Hey. Cool. All right. I'm going to switch over to the thanks screen and we'll see if it works. Okay, you're muted.